Bismillahirrahmanirrahim. Now we are going to start the most important and especially for the student a little bit difficult chapter, which is called projectile motion or two-dimension motion. So in the next page we will study about that what is two-dimension and what is projectile motion. So let's see what is this. Okay, here in the definition given, projectile motion is two-dimensional motion under the constant acceleration of gravity. Now let's see what does it mean, the projectile motion, what is two-dimension motion, and under the action of acceleration. Let's see one by one this point. For example, if we have object and I give some initial velocity, like here if we have object and let's suppose this is the ball, if I apply some initial velocity, so after some time it will follow the path like this one. So we have this object will move like this path, so we apply some initial velocity and this object make the angle, like here it will make some angle or theta, which is denoted by theta, with the horizontal side, like this is the horizontal side. So under the action of gravity or under the action of what, constant acceleration, so this is called projectile motion. So through in this all motion, the acceleration or gravity due to gravity will be constant. So now let's see what does it mean. Projectile motion is two-dimensional motion. Now what is two dimension? So before this we already studied the one dimension motion. One dimension motion mean like when the object follow the straight path like this one, so this is called like the object for the horizontal side or the object for the vertical side motion like this path. So this is called one dimension motion. But here if this ball is follow this path, so here it will affect on both side, horizontal side as well as vertical side, mean this side also increase and this side is also increase. So that's why this is called what, two-dimensional motion. The next one, under the action of what, constant acceleration, is I told you this motion or throughout in this motion the acceleration will be constant, because we know that gravity value is 9.8 or normally we can use 10 meter per second square. So now the second word is trajectory. What is trajectory? The path followed by the projectile motion is called trajectory. Mean when this ball or object move on this path to follow this path is called what, trajectory. So and normally like in mathematics it show like a parabola structure. So this parabola structure is called what, a trajectory. One thing remember here, projectile motion, in the next page we are going to the most important, we will prove some equation, like one is special case, one is general case. In inshallah next video we will find the equation for range of projectile. The next one is like time of flight, horizontal distance, in height of light. So now remember one thing, like in this when we discuss the projectile motion, so we consider there will be no air or frictional force, we will neglect the air resistance force, only we will consider the gravity force in the projectile motion. So let's see on the next page what happened, or we are going to study more about the projectile motion. So let's see here, like sometime we have this a normal case is when we kick the ball or especially like the cricket ball, like the football, they follow the projectile path. But in some condition, let's suppose if the ball is on a certain height and we gave some horizontal velocity like that one through horizontal, so after some time it will also start the projectile path, it will follow the projectile path like that one. So in that position we give some velocity, and this velocity is denoted by vix, mean initial velocity on horizontal side. So this velocity and this velocity in this through all path will be same. So after some time, like in this part there will we will not give any vertical velocity, mean the vertical velocity is what, 0, viy is equal to 0, but only we apply some or initial horizontal velocity when the ball is reach here. So here both velocity is produced. The initial velocity on horizontal side is already the same with that one, but here the new velocity is also produced, which is equal to viy throughout up to this part. So now what is special case? In special case we are going to find one thing. Remember here, let's suppose if we apply the 2 meter per second initial horizontal, so this will remain same in this whole path. Because why this will remain same? Because we said that we will what, neglect the air resistance force, and if we neglect the air resistance force, so the horizontal velocity will remain same. So now here we can find the two things, mean this distance and this height, which is denoted by y. So if we find the this x or displacement, so we know that velocity is normally equal to v is equal to delta x t. So here I can also write this equation like that, sorry, delta x divided by t, like that one. So I can also write this equation delta x is equal to v multiplied by t, if we multiplied both sides by t. So here this x or displacement we can denote with the help of x, and initial velocity on the horizontal side we will denote vix. So we'll, instead of v we can write vix multiplied by what, time. So we can use this equation to find the distance on the horizontal side. Now on the vertical side, let's see here in the special case. For the vertical side we can use the second equation of motion. Like the second equation of motion, we know that delta y or delta x is equal to vi t plus half gt square. This is the second equation of motion. We already proved this one in the previous video. So now here the delta x is equal to y if we want to find the vertical side distance or displacement. So this is equal to y, and here this vi is equal to viy t plus half gt square. One thing remember here, like it the initial, if we know that the initial velocity on the vertical side is equal to what, 0. So if we put the 0 here multiplied by t plus half gt square, so we this component will become what, 0 plus half gt square. So now the y will become, or this height we can find with the help of this equation, half gt square. So now in special case we find the two equation. If we have the projectile motion, like if there is some ball throw on the certain height, so we can use the, for the distance or displacement, the horizontal distance, we will use this equation, and for the vertical distance or displacement we will use this equation. So on the next case, our general case, now let's see what is general case. in general case, mean normally we have a projectile motion like that one that we already discuss in the definition with the definition of the projectile. So let's suppose if we have the object and we apply some initial velocity which is denoted by vi, so in after some time it will the body will not continue the this like this motion, so because of the gravity it will follow the projectile motion. So after some time, this initial velocity is converted into their component like that one. This is the horizontal, this is vertical, this is the horizontal, this is vertical. So now let's see here. So how can we find the component of this initial velocity, like in the previous lecture or in the vector component, we know that how can we find the component of force, like this is the force, so this part is base which is equal to f what cosine theta, f of x cosine theta, this part f of x is equal to f cosine theta, and this side was equal to f of y f sine theta. So here this part is the base which is equal to, now we can write like this, vi x side mean the base side which is equal to vi, like here I write here f cosine theta, so I can write here vi cosine theta, and now the vertical side this one which is equal to viy, so which is equal to vi, now here this is equal to f, so here is vi instead of f, and sine theta. So we can find the component of velocity, this initial velocity, with the help of these two formula. Now if someone asks the question, let's suppose to find the final velocity at that point, let's suppose final velocity at that point, so how can we find the final velocity? So we will draw the again the component of final velocity. Now we know that final velocity is denoted by vf, which is equal to v f of x plus into f of y, like this is the base component, this is the vertical component. Now how can we find this one? So v of fx component, we know that here, like if we again I can say one thing, if we neglect the air resistance here, so the horizontal component motion we already studied about it, the horizontal component velocity will remain what, same, there will be no change happen in this horizontal component. So horizontal, this is the horizontal component or base component, so we can say this is equal to vi x, and vi x is equal to vi cosine theta, like now we have v of x, the final velocity base component is equal to vi cosine theta, so no issue for that, this is easy. But the problem here is for the vertical component of the final velocity. Now for the vertical component velocity, I can use the first equation of motion, which is equal to vi plus at, like this is the first equation of motion. So now here if I use this first equation of motion, so in the general case, this now divide the velocity, now this is equal to vi y component plus, if we know that this motion is because of the what, gravity, so this a will convert to minus g, and with what, time. So now again write here vfy component, this part is equal to vi y minus gt. Now we know that vi y is equal to if we use this side, vi sine theta minus gt. So this is equal to for the final velocity component. If we want to find the final velocity, so the first part horizontal component is equal to vi cosine theta, and this part for the final, to find the final velocity, so this is equal to vi sine minus gt. So now if they ask the question like for the component of vector to find the magnitude, if generally in the component of vector, if we want to find the magnitude of this force, so we use that formula like F is equal to F of horizontal side on vertical side. So here same, if we want to find the direction of the final velocity, we can use Vf of x square, like this formula, Vf of x square, this one, and the second one we can use this part Vfy, use this formula. If we find the value of Vfy or Vfx, so then you can find the magnitude with the help using this two part. So now if they ask the question to find the direction, so very simple, use the tan inverse, and vertical side mean Vfy side divided by Vf x side. So that way this will give us the direction and this will give us the magnitude. So thank you so much for today's lecture. If you have any question, I know this is very difficult, so you can ask through in your comment. Just follow our channel, and best of luck. So inshallah we will continue in the next lecture. Range of projectile, height of projectile, and time of flight. We will also prove the equation for this all of these. So thank you so much.